This podcast was produced from a webinar. For a more interactive experience with visuals, visit advancedmanufacturing.org/webinars.
Hello, everyone. Welcome to another SME Media webinar. I'm Rachel Thomas, editor. Today, we will explore the topic, Designing a Smarter Manufacturing Sector, how winning manufacturers put historical data at the center of their business transformation. This presentation is sponsored by CADDi, and we're joined by Aaron Lober, Vice President of Marketing, Chris Cope, Vice President of Engineering, and Patrick Harrigan, Vice President of Partnerships, all at CADDi. Now it's my pleasure to turn things over to Aaron. Welcome, and we're happy to join you today.
Yeah, Rachel, thank you so much. I really appreciate the introduction. It's a pleasure working with you. And to Sam on the back end from the SME team, thanks so much for helping with the production today. And to everybody who joined us. You know, this is a really fun topic for us, and we're happy to do it. This topic is, it can be very tactical, and we're hoping that ultimately what this equips everyone with is a very clear view to how, the current paradigm of technology and transformation in manufacturing may not be serving you adequately, and hopefully walking out with some ways that you can think about deploying historical data. But that's the beginning of a preamble, right? I think the thing that I have been meditating on as we've been preparing for this webinar is why I think this topic is so important. Designing a smarter manufacturing sector, another way to put that, right? Unleashing the potential of manufacturing is really close to my heart and to the heart of most of the folks here, because it's our mission at CADDi. It's our core mission. I'm sure those of you who have joined us in other webinars are maybe anticipating us talking much more deeply about artificial intelligence or AI readiness, or maybe even if you came to our first SME one, reactivity to tariffs in the uncertain tariff environment. But using historical data to unleash the potential manufacturing here in the US and around the world is really what animates or motivates so many of us here at CADDi. Now, of course, I couldn't have this discussion without my compatriots, Patrick and Chris. So, fellas, I just want to take a moment for maybe the folks who haven't joined us before and have you guys introduce yourselves really quickly. Chris, if I could throw to you first, maybe just sharing what brings you to this moment.
Everything brings me to this moment, Aaron. So I've been building products for over 20 years. I've been building AI products for over 20 years and training neural networks. And so I'm really excited, really in the last, especially like 3 years with the CADDi platform, of how everything has kind of brought up to this point where we can make really, really impactful changes in manufacturing and in things that impact our daily lives.
So, Patrick, Chris is obviously the smart guy among the three of us, but you have the deep manufacturing background from your time at Hexagon and then with Tulip. So, share a little bit about yourself, if you don't mind.
Yeah, happy to. So thanks, everyone, for joining. Patrick Harrigan, based in Atlanta. I've spent my whole career in the manufacturing sector. Spent a lot of time on the operational side. So I think one of the things we'll talk about today is a lot of the trends we see in digital transformation are heavily focused on production and operations, not as heavily focused on what I would call more back office centric activities. We want to eliminate waste and apply lean concepts to all areas of our business, but one area has been getting all the attention, not so much the other. So I'm excited to talk a little bit more about that here today.
Yeah, that's a great tee up. Honestly, that rolls me into the last thing for me to say before the real preamble and setting the stage for the problem. What we're going to try to do is set the table here for what will hopefully be a very lively discussion between Patrick, Chris, and myself. But we need to do that by first sort of exploring the productivity crisis that's facing manufacturing companies today. I'll speak a bit about our view on the root cause of that crisis. I'm also going to talk a little bit about, as Patrick teed up, concepts of digital transformation. I'll use that to sort of highlight some of the areas where transformation, or the current transformation paradigm that's gotten very popular over the last decade, has maybe sort of missed the mark. Maybe an overemphasis on the shop floor and an underemphasis, or some neglect pointed towards the back office. Then fortunately, Patrick's going to follow that up with something real, physical, tangible, in a demo of what CADDi does. So helping set the table for how we offer a different pathway than some of the classic PLM, PDM providers. And then together, we're going to get into some of the really smart use cases that CADDi customers are pioneering. And then finally, we're going to wrap this all up with some discussion of what we think really matters today, and how you can all, or we collectively really can all, move forward in designing a smarter manufacturing sector. So we're going to try to do a lot. It's an ambitious goal, while still leaving time to answer any questions you may have. So I want to just say one more time, anything that's interesting to you, drop it in the chat, and we'll do our best to touch it at the end. This is where I think, for me, our story really starts, though, if we want to anchor on pain. There are a lot of scary stats to be found in modern manufacturing. One that I think about a lot, there are 30% fewer manufacturers in the US today than there were 20 years ago. Another, the lack of skilled labor is likely to cost the industry over $1 trillion in lost productivity in 2030, which is closer than I care to admit. Yikes to 2030, right around the corner. The worst of all of these stats for me, however, is this, which you see on screen. Labor productivity has really stalled over the last decade, and it looks like actually it's rounding the corner into negative territory. And this shouldn't be possible in a country with the very best educational system in the world and access to the most resources and capital of any developed nation in history. Like, it boggles the mind that this is where we are. This, by the way, small aside on this topic, but working for a company with Japanese roots, you start to develop an appreciation for the seriousness of this type of stat really quickly. The combination of an aging workforce with inadequate systems for turning over institutional knowledge to the next generation, or like no plan for enabling the next man up, so to speak, is the opening act of a manufacturing crisis that can reverberate through the entire society. If you don't believe me, I invite you all to do a little bit of research into the global share of manufacturing that Japan dominated in 1980 and look at what it is today. They may be a few decades ahead of us, but that's not a curve that I would like to mirror for the US if I can avoid it. Okay, but that said, productivity is a problem. It's starting to stall. What's actually happening underneath the hood? This is the thing that we have to explore, right? If we want to make any changes, if we want to do anything actionable, we have to sort of do some type of diagnostic around root cause. So I know with that first slide, I'm sort of storytelling at a slightly higher elevation than we can do that at. And it's a little pithy to say we're not setting our people up for success. So I think this is instructive. As we get a couple of layers down, looking at what needs to be addressed here, there are essentially 3 fatal flaws by our estimation that are a drag on productivity and are going largely unaddressed. The existence of departmental silos, unmitigated or unregulated rework across the manufacturing process, and poor data access for every member along the workflow. And I'll break those down one at a time. So hopefully these all make sense intuitively for most of you, I'm sure. Manufacturing is a workflow. Many people need to participate, many hands making this light work. Decisions made at every phase along that process can have a cascading impact on the outcome. at the end of the day. So departmental silos are actually a natural byproduct of adopting specialized processes and tools to do one's job, but they're a killer for overall productivity. So this is one of the core, we will at a number of moments throughout this presentation stop and say, like, this is one of the deepest problems inherent in the existing paradigm of how we do information technology supporting manufacturing. This is, I'll say later something about sort of my view on the original sin of the PLM paradigm, but this is a major problem. These processes and tools might help you as an individual do your job, but the fact that we have seen massive tool sprawl across manufacturing over the last 10 years, but labor productivity is starting to turn negative, says we may be making individuals very efficient, very effective at doing one piece of the, or putting together one piece of the puzzle, but we have not effectively enabled teams to run through the entire manufacturing process more efficiently. Rework is the second piece in here. This can come about, for a lot of different reasons, from the choices that others make, right? A la call back to departmental silos. Rework can come about from user error at basically every level. Sometimes, honestly, rework actually plays a positive role. Like rework isn't all bad. If we're going through the prototyping process, we may have some acceptable amount of rework. That said, the bottom line is rework is a drag on productivity, and it needs to get addressed. The less of this we do, the faster and more effectively we're going to move through the motion of designing new products, manufacturing those, ensuring they meet quality standards, and getting them out to market. Often, rework is actually coming about because the data that's needed to inform the right decision simply isn't easily available for folks. So, teams may be struggling to find or reuse past designs, for instance, due to inadequate data systems that result in duplicated effort and wasted time. This is pretty common, in fact. Patrick and I talk a lot about, just zooming in on the engineering department, how much time is spent at every phase of design on just finding information, looking for historical data. It would boggle the mind if you really got under the hood on how much time is spent there just on search. So, look, with all that said, I know the elephant in the room here is that AI has accelerated the need to get these things right, and we really haven't even mentioned it yet. I promise we will. We'll get there. The point, though, before we get into AI is manufacturers need to transform. Or we risk ending up much like our Japanese counterparts, which I think is, suffice to say, a non-optimal outcome for many of us. This is the phase, then, if we're going to talk about transformation, that I need to do just a little bit of definitional keyword play here. I know in this keyword portion that some of you are going to be well familiar with these concepts. So apologies in advance for the folks who feel that this is a little more 101 when you showed up maybe for a 301 discussion on leveraging historical data. But I think this is important for us to just level set so we don't lose anybody as we talk through this idea of transformation. Now, if we want to talk transformation, we need to understand basically the process of getting there. And that starts with digitization, right? So digitization, simply put, is just the process of converting analog information into a digital form. So most manufacturing operations have figured out a way to do this, at least in terms of the new information that they're starting to create, right? So if you are working on, or if you're working in a digital CAD tool and you're no longer hand drawing your designs using, say, a slide rule, you are producing a digital data point, right? You're invested in digitization. This is a really key first step in affecting a transformation, because until your data and information on manufacturing becomes digital, it is very hard to leverage and deploy, broadly speaking, to transform your systems. And that's sort of step 2, digitalization, right? So taking individual digital data points and starting to use those to transform work process to a degree, right? So the process of digitalization is now, I'm not just going to create a singular design file. All of my design is going to take place digitally, and we're going to build the beginning of an understanding of what type of design works and what doesn't. Anyone who's gone through PLM implementation, by the way, is going to get this point. For most of us, this process of moving from digitization to digitalization knows that the tools we've been pressed to adopt won't touch legacy or historical data, right? So this is essentially, from this point forward, we are going to operate digitally. We're going to move our workflows into a digital paradigm so we capture data, so we can operate more efficiently. But legacy data and information is lost, right? You can only really start leveraging a digitization from the moment that you adopt the tools. And that is a major gap. Like that's a gap ultimately that we, as CADDi are hoping to fill. I know I teased early. I said, in my view, this is sort of the original sin of the PLM paradigm. But we believe we can fix it. This is kind of key, right? Leveraging historical data is actually, in our belief, the key to effective transformations, because in the absence of it, without doing that, you are really missing out on a wealth of knowledge and information that should be informing your business decisions today. The reality is 80% of all manufacturing data and documentation still exists in some type of non-digital format. It's likely sitting in a file cabinet in your back office somewhere. Legacy documentation almost never exists in a digital format today. And no one is really converting the lessons that are contained in those file formats into your current work process. And sadly, that leads to a ton of rework, as we've already pointed out. The popular paradigm, then, if you will, this is what I'm really trying to tee up. The entire transformation paradigm that's been popularized by companies like Autodesk and PTC is missing the vast majority of the context that you need to actually improve productivity. It's not enough to just take existing workflows and make it digital from this point forward. Like, that's good, but it leads to you making the same mistake that your team made 10 years ago, just now in a digital interface. So to really improve work process, you need to start integrating into the vast learning of your company's operational history. So as I said just a moment ago, you can avoid reinventing the wheel. Now that means tapping into everything from design to supply chain documentation to work instructions. Like, the list is long. And that is what we believe the PLM providers have missed. So I know that's a lot to get us around to. This is ultimately where we come in. CADDi is a data platform, AI powered, that's here to circulate institutional knowledge and unlock productivity. So we're going to help eliminate data silos. We're going to help reduce rework. We're going to help you democratize access to your historical data, and we're going to put all of that historical data to work. So this is the perfect time for me to hand over to Patrick now to sort of get into how we do that. And then we're going to transition and talk a little bit about who's doing it already, so you guys can take some of the learnings there. So Patrick, I know, per usual, I talk more than I should, and we're 20 minutes in, but I'm going to let you share screen here and take things away.
Yeah, sounds great. I just want to confirm you can see my screen.
I can, yes.
Okay, great. Thank you. All right. No, I think it's important context to go into what we're going to show today. Maybe a few key elements to touch on. When looking at modern digital solutions, especially around digital engineering or procurement solutions, Aaron is spot on. The primary focus is if you're going to digitize, let's take it from today forward and really ignore quite often decades or centuries in some cases of decision making and problem solving that exist within these more legacy data sets. So think of paper-based documentation that either is uploaded as a PDF, and this is best case scenario, uploaded as a PDF and exists in some file folder somewhere. Worst case scenario is it's in sheets of paper and folders existing in filing cabinets, in which the majority of our customer base still has in some capacity in one or many of their facilities, or things like not even being on paper. I mean, we're talking engineering documents that were still on microfiche or on fabric-based documents. They're not even on modern paper. So the idea is, how do we leverage all of that information so that we don't have to reinvent the wheel when solving very similar problems and challenges? The reality is, if our company, if our manufacturing organization's been in business for 10, 20, 50, 100 years, we're probably making very similar parts, components, assemblies throughout that entire duration. Not exactly the same, but somewhat similar. And how do we leverage all the historical decision making as part of that? So this, what you're seeing here on the screen, is CADDi drawer. So think of a drawer to a filing cabinet in which these papers were stored at one point but no longer are. What we do is focus on taking all this legacy information, we call it unstructured data, and converting it to structured data so it can be much more searchable, findable, and usable. We'll focus a lot on engineering documentation for today, but the reality is this is any type of documentation. So if you have specification sheets, if you have quality inspections, quite often going into our manufacturing customer base, looking at hand-drawn or hand-filled out quality inspections or non-conformance reports, design review meeting minutes. So nowadays, with every meeting being online and recorded in some capacity, we get a printout of everything that was discussed. How do we quickly upload those meeting minutes into something like a CADDi so that all of that tribal or tacit knowledge that's shared within that meeting is now leveraged for future decision making? So if we want to make a change to a design, or we selected this supplier over that supplier, what is the context around making that change? Why did we do it? And how do we serve up that information 1 to 5 years from now when someone's trying to make a very similar decision without having to go through re-engineering processes or problem-solving mechanisms? So I want to show you today a little bit about CADDi and some of the cool search feature functions and how we serve up this information in a very meaningful way. I'm going to start here with a simple example. This is a part, this is a shaft, very simple, standard engineering drawing. We have things like a title block down here. We have models that we run on top that scrape the text and numeric values, again, unstructured data, and convert it to structured data over here on the right-hand side of the screen. You see here is a big block of all of the numeric values and text that have been extracted here. That is automatically filed so that you can start to say, okay, what's the drawing number coming off of all of these documents, or the part name, or the material, or whatever information's on here, being able to quickly structure it so it becomes searchable. The idea being, I can search on all this data now in the same way you would search in Google, show me all shafts with this material, without this. All that type of advanced searching functionality is now available on your engineering documentation. Again, quite often a data set that exists in some file folder somewhere that no one's touched in many years. When you have to go actually look for that information, it's incredibly painful. Hours of searching through different folders trying to find specific pieces of data. The next thing we do once we have this data structured is we start to draw correlations with other associated data sets. So in this context, do we have any CAD files that are associated to this drawing? In this case, we do. We actually have two different CAD files. What's the purchase order history associated with this part? So in many cases, in most cases, is data coming from your ERP system. So who was the supplier? What was the quantity? What was the lead time? What was the surface treatment? All of that information that, again, historically disparate systems is now part of this unified view. If we are a contract manufacturer and we're actually reselling some of these components, what were the sales orders associated to it? I provided the example a moment ago of design review meeting notes or corrective actions. We had this issue when manufacturing. We had some DFM challenges. Why did we make these changes? And can someone leverage this data in the future? Quality inspections. I'll just pull one of these up for a simple example, but this is all historically PDF or document-centric type of data. It doesn't have to be that. It can be well-structured table data. But in the context of leveraging the historical information, most cases it exists in this type of format. And we're able to draw the correlation between the part number here listed on this document and certainly the part number we're extracting from this engineering document. So now we have this full 360 view. Great. I want to know everything associated with when we designed or manufactured this part. And can I leverage some of this data to not reinvent the wheel, potentially use this part or drawing as a starting point when engineering a similar part or drawing? Which brings me to our next cool feature, which is really around this idea of similarity search based on the shapes and geometries that we see on this engineering documentation. So up here in the top right, there's a similar button. When I click this, what CADDi does is it takes the shape and geometry from the inner workings of the image you see here and really excludes the text and numeric values in most cases. So we want to say, does this shape look like any other shape that exists within our portfolio or our data lake here? And in this context, we pull back a whole bunch of different shafts that look very similar. This allows us to quickly identify things like parts families, solving the question of, hey, have we ever done something like this before? It could have been 2 years ago, could have been 5 years ago, could have been 20 years ago. But if so, we want to quickly surface that in the information associated to it. So, okay, these shafts look fairly similar. Did we purchase it from did we have the same supplier? No, in this context, this was Ohio CNC and this was Herman CNC. Did we have quality issues when we actually went to go manufacture this versus the one on the left? Did we have any issues with the supplier on lead time? Of the 20 shafts that we see that look very similar, what is the average cost per unit that we were seeing? So some should costing analysis. So all of this data and insight and analysis now quickly becomes available at your fingertips. And in most cases, this is a net new data set that we've never been able to search like this before, using things like similarity search on shape. So really cool, exciting ways. The other element is, you know what, this is pretty similar, but not identical. Do I want to see how similar it is? We can quickly show and identify differences. Well, this extrusion or this hole is here, but not there. So being able to quickly overlay these documents and say, you know what, this is pretty close. Maybe rather than redesigning this product or creating a new SKU, I can use this existing component we have as a starting point. Cool. So that holistically is some of the cool features of what we're trying to do when we say serve up legacy data. One other example I want to show when we talk about things like assemblies or sub-assemblies, the ability to extract BOMs from this legacy engineering data, which you see, I can't really zoom in too much here, but you can see in the bottom right here. When we upload this documentation, we're able to extract all of the BOM information and we store it down here, which shows me all of the parts and components that go into this assembly. And if I want to drill into a specific part and see, okay, here's here's a plate in which was associated in that assembly. And I want to say, you know what, this plate is no longer what we want, or the supplier is no longer in business, or what have you. Have we ever created any similar plates to this in the past? And I can hit similarity search. And so it really allows you to, without knowing every aspect of what was assembly, what was a subassembly, what were the parts and components as part of that, and trying to follow the historical file structure or folder structure, which requires you to properly tag all of this documentation. You're now able to search and find this information much, much easier, making better, smarter, faster decisions. So Aaron, I could spend much more time in here, but the reality is I think without boring everyone too much, that's what I wanted to show today.
I really appreciate it. I love when we go through that, because it really highlights, I think, for me every time, Patrick, just how important it is to be able to access all of these different modes of historical information. I think that's really critical, obviously, because as we teed up earlier, there is a workflow here, right? Manufacturing is a workflow. And for engineers and procurement folks and sales folks and folks on the shop floor to do the job really well, they all need access to different data points. So we're doing our best to serve those up. Whereas maybe, you could say the PLM solution is verticalized. It concerns itself with the connection between product and component data, and it has workflows for finalizing designs. And say the ERP, really concerns itself with, let's say specifically, cost or supplier data, purchase orders. Again, it's got verticalized workflows for handling those. CADDi is actually a horizontal solution that's acting across all of those in order to make sure that all of the information contained gets play. Now I'm going to cross my fingers and hope that we actually are now showing the first case study that I sort of wanted to talk about. Hopefully I can get a shout out. Yeah. Okay. It looks like Denso might be up on screen there. Chris, I was wondering if you could tee this up, and we can obviously go in depth talking about how we are helping Denso, both on the procurement and on the design side, but fundamentally how we're helping them leverage historical data to transform the business.
Yeah, absolutely. So Denso is one of my favorite customers. I always having done tech startups before, or having built tech startups. Usually, tech startups want to focus on a small customer. They want to focus on small customers, young customers that are sort of easy, like early adopters that can adopt a platform and really move the needle because it's a small needle. One thing I like about CADDi is we don't do that. We go after companies like Denso. They've been in business for, I think, almost 100 years. $50 billion a year in revenue, huge manufacturer. And with I think they have over 100 factories. I believe they have like over 100 factories. So you have a big customer, huge operations, many decades of data. And of course, this is what happens to a lot of our customers. They don't have an ERP system. They have dozens of ERP systems and dozens of PLMs. And so, we're at this, like there's this sort of moment right now where I think a lot of the hopes about what AI could bring over the last couple of decades have really kind of become true the last few years. And so you can see a customer that, they've made investments in digitalization. They've made investments in these platforms like ERPs, where they have to organize their data and onboard, but no matter what they do, right, you still have all these different parts of the business. They have different workflows. You're never going to be in sync with one of these traditional systems where, if you look at most of these systems like an ERP, it's a platform that you adapt to. It doesn't adapt to you, so that when you create and put data there, it's very easy to search for. with AI, you could just search through everything, everywhere, regardless of where it is. So yeah, so I think the big thing for Denso is we've basically doubled the speed at which they can select suppliers, right? So that is a huge thing to do for any manufacturing company, especially one so large. And I think that's what's really exciting about working at CADDi, is that we get to interact with really, really large customers and help them move the needle.
Yeah, I also love this example because I also like diving in with this team because there are so many facets to the business. For them, the idea of the speed at which we select suppliers has a direct impact on lead time, on how fast they deliver product to their customers, and how often they, maintain. I mean, this is a huge business, right? So win new contracts, maintain existing contracts. Operating in the global supply chain, especially when they work with the big American automotive manufacturers, there's a lot of downward cost pressure placed on suppliers like Denso. So, if they have to go get 3% every year, making sure that they can effectively select suppliers who support that for their component parts is a big part of it. Obviously, also we play a role with helping transform the way that they go through design standardization. I was really struck by how important it is for these guys to surface for their engineering team when work has been done in the past to help eliminate duplication and redundancy, because the information shared on the cost of developing and maintaining in inventory a redundant part is pretty staggering. But this is a really great one. Is there anything, Patrick, you want to comment on here before we maybe talk about our next example in Kawasaki?
No, let's go ahead.
All right. I love this one too. Chris, maybe you can tee this up for us. Kawasaki Heavy. This is one of the originals.
Yeah, Kawasaki Heavy, same thing, right? It's in this case even a larger reduction in the time that they're looking at charts, right? They're not selecting suppliers twice as fast; they're selecting them 3 times as fast. And I think that we're seeing this again and again as we help more companies. And the thing that again I'm just living my best life, having done AI for 20 years, and it's moved from something that is very cool in research environments to actually helping real manufacturers, is how quickly we can make these changes. What's happened right now really is that this sort of traditional enterprise software model has been really turned on its head. What's happened is you have all these everyone's used to this model of you sign a 3-year software license with some company like an ERP. You spend 6 to 12 grueling months that first year adopting the system to start to get a return, to start to see changes. We get to do that in weeks, right? Because we get to see that ROI in weeks, because we're able to. You don't need to organize the data and then put it into CADDi. You just put the data into CADDi. Then you're immediately deduplicating your data, identifying things that are very similar. Maybe you want to make them duplicates, maybe not. You get to decide how to organize your data, how to organize by what categories it's in. Should it be in different projects? All of these things, which I think that the time to value of new AI native platforms like CADDi are just turning the sort of traditional engagement model on its head. And I think it's really exciting to see us come into large manufacturers that are name brands that have been around forever. They're so incredibly efficient at making something at volume and at price and at super high quality, and then we're able to just help them be so much more competitive regardless of the sort of past investments they've made or not made in digitization and enterprise software adoption and cloud adoption and all that sort of stuff. It allows them to just catch up to be hyper competitive immediately.
Yeah. Well, that idea of being able to catch up, we're going to circle back to in a second while we do discussion. But the thing I wanted to share about Kawasaki, this is one of my favorite groups also that we've been able to work with. In a sense, the Kawasaki heavy team is sort of like a unicorn customer group for us because as I said earlier, right, teams who are going through this transformation, digitalization, often are thinking about the way that they transform their individual workflow. And so engineering in a vacuum, procurement or supply chain or manufacturing in a vacuum can make themselves really efficient, but they often lose the context of the full operation when they're not working in teams. And the original user group at Kawasaki Heavy who came to CADDi was actually a cross-functional team that was tasked with identifying cost down opportunities. So this is a mixed group of engineers with value engineering backgrounds, supply chain stakeholders, corporate planners, and the very first thing that they were looking to do was basically tee up the value analysis, value engineering process to see what could be achieved there. And the big pain or the big barrier that they were running into was very, very limited access to the types of historical information that would help inform where they can consolidate suppliers or what types of impact on cost their engineering decisions were having. And of course, in that, in service of that pain, the very first thing that we did for them was basically ingest data and interlink all of these design and supply chain data points. So they could start to say, hey, in fact, we have this big opportunity to reduce direct procurement cost on a couple of these product lines through a little bit of supplier consolidation. And hey, in fact, we have some opportunities to standardize design here and eliminate a little bit of redundancy. But the folks who were doing that work were this phenomenal representative sample of every member of the workflow that is manufacturing. And so I think about that all the time. And not every business is there yet, where they've empowered a group to work this cross-functionally. But I always thought about it as something that we as an industry should be aspiring to as often as possible. Okay, so what I want to do, because we still have a little bit of time remaining, is dive into some of these things that we've already been talking about. And Chris, Patrick, I'll go to you first, right? Because you're the one who introduced this idea to me of the data historian and it not existing for the back office. But we've said already, right, that legacy data is being neglected. I've offered up at least one justification for why that is, related to it's tough and folks are working on transforming individual workflows from this point forward. But why don't data historians exist for the back office? What is a data historian and why is this concept significant to our discussion here?
Yeah, I think it's very much in line with maybe the comments I opened up with. If you look to the operational side of the business, we have assets. We want to know how these assets are performing. Historically, we've gone through decades of transformation where we're putting sensors on these assets, and we basically know, what's running, not running, how efficiently, where can we make things more efficient. That's the huge IoT push that we've had for the past 20 years, and it's really brought a lot of advancements on the operational side. What I find interesting is if you take those same concepts and look to departments like design and engineering or procurement or sales or quality, do we have these rich decades worth of data sets that we can leverage when making when decision making or problem solving. The reality is no. The best we have is an ERP that's been in place for 15 years, of which you'll never be able to find any information you're ever looking for. So it's a really interesting idea to me that it presents a major opportunity for most manufacturers. So if you think of the world in a pendulum, the past 2 decades, a pendulum's been focused on reducing waste on the production or operation side. Now that the low-hanging fruit is gone on that side, the pendulum of transformation is actually starting to shift back towards the back office. This data set that we've used to solve all these problems historically is not in a digital format in 99% of organizations. And there's no switch, there's no sensor you can go put on our engineers in order to instantly start. Very manual process to get that unstructured data into a format for us to actually take advantage of. The AI, I mean, that's why we're here. Without the advancements of AI, we would still face that big uphill challenge of converting that unstructured data to structured data. But technically where we are, that is no longer a challenge. And so now it's time for everyone to really start looking at that data set as a new opportunity to really start getting value out of that. Historically, we just threw our hands up and said, it is what it is. We did some great things in the past, but those will stay in the past. Hopefully we can do great things in the future. I'm not sure if that left you speechless or
it did. No, it did. I'm so glad that I left myself on mute when I made my worst joke of the day. It's to everyone else's benefit. Really channeling my dad with that one. Chris, what I want to ask you is, okay, so investment is shifting towards the back office in order to apply historical data to fuel transformations. But why aren't, I can ask this in 2 ways, right? Like, why aren't people tackling this type of data ingestion, analysis, and leverage in their PLM, or why haven't the PLM providers set up people to do this in their systems?
Yeah, that's a great question. So I think there's 2 questions. I think there's 2 answers. I think one is that I mentioned this sort of model of engagement before with enterprise software, where you sell a 3-year software license, you spend 6 to 12 months, which is really like a big consulting fee to do the onboarding and help change the workflows and everything like that, right? We all know that model. And so you're incentivized not to go really fast, because if you build up a partner network, if you go really fast, you're basically kind of losing money if that's the business model. So I think part of it is there's not that much incentive to do that. I think the other thing is that you mentioned describing systems as horizontal and vertical types of systems. So a vertical type of system is focused on that. Your ERP is focused on order history. It's not focused on part versioning and everything like that. Your PLM is focused on on design versioning. It's not focused on order history. And so you're not going. Those vertical systems are not necessarily again focused on how do I integrate with all the other data, because I'm trying to maintain this workflow here. The reason why is that historically you need to architect a system so that when you create data and put data there, it's easily searchable, right? These large language models have completely changed the way we search for data with vector databases and embeddings and all that stuff that we do. So I think that's part of it is that CADDi, we come to manufacturing companies not trying to sell them a software that solves that they rely on for some vertical. and they have to adapt to our platform. We're really just trying to give them insights across everything in their platform, and and the goal is to keep innovating and making new products that do that for different teams in the company. We haven't mentioned CADDi quote, but some of the stuff that we were talking about with the two case studies. We have other software with other parts of our platform which say like, hey, use it for this RFQ you're creating, use this supplier, don't use this supplier because of all this historical data you have. Even though you could do that like specifically like for that procurement team, right? And so I think kind of going back to the Kawasaki example, like when you have a cross-functional team at a manufacturing company, it's really hard for them to work in one platform because there's all these vertical platforms that their workflows are tied to. The design team is not going to have access often to the ERP. The procurement team may not have access to the PLM, and so I think it's just a completely different way to approach things, and that's why you're not seeing that, right? Because you're not incentivized. If you're these vertical systems, you're not incentivized to build collaboration between those systems and between those teams.
Yeah. I mean, I think about that too, in terms of our business strategy. This is one of the things that makes me confident that we're going to be here and the only folks really tackling this problem, while the Autodesks and PTCs of the world are, and Oracle and SAP are really focused on their vertical approach. I know we've only got a little bit of time left, and you said something to me in prep here, Chris, that I really wanted to circle back to, because I think this is maybe the thing to like leave folks with. We were talking about the investments that companies have made in digitization and cloud service over the last several decades, and the perception that can create. If you're, say, behind the curve a little bit, about being just behind the eight ball, and the fear that the gains that your competitors have made by being first movers here compound endlessly and you'll never catch up. And I'm wondering if you can share a little more about that and how maybe your view is in this moment that that may no longer be true. Part of it's AI, but there might be an opportunity for folks to catch up here with the right application.
Yeah, that was an interesting conversation we were having. So I think that AI is making it easy for a company to be hyper competitive, like now, like this quarter, right? And so it's great if you've made lots of investments in digital transformation, 10, 20 years ago, if you've made a lot of investments in cloud modernization in the last 5, 10 years, all these big advancements that you could have invested in IT, and the software and transformation, everything. While it's better to have made those investments, if you haven't really made those investments and you feel like you're not catching up, you can kind of just immediately jump to the front with AI, because like I was pointing out earlier, the cost of deduplicating your data is now effectively zero. The cost of automatically linking all the documents in the demo, right? Automatically linking all the documents related to a design is now zero. It just happens. The cost, like, you don't have to spend all this effort, change your workflows, change everything, organize everything, and then go adopt a platform. You adopt the platform, you connect your data, it's all there, and then you can actually even like understand what's the data we actually have. Oh, we designed the same bracket 80 times in the last 20 years. And they all have different supply chains and they all have different quality history, right? But now we know that. We didn't have to go and spend all the time, because every company is just trying to serve their customers, they're trying to manufacture, they're trying to source parts, manage their supply chains. They're all working all day. They're not also able to do all this. So the great thing is, like, now the cost to to sort of modernize yourself and become super competitive as a company has gotten to near zero, which means you can make that investment and just start moving.
Yeah, it's an incredible moment we're in. Now, okay, I know we're at time, so any remaining Q&A questions we'll make sure to answer over email for everybody. As you know, we shared the recording and slide materials, but I wanted to leave you here. So just with a call to action for everybody, you know, the world's top manufacturers are already doing this, and as Chris just so succinctly pointed out, it's very important that you take seriously the opportunity to leverage AI to do some of this now. You know, there's no better time than the present, especially given how much lubrication technology has provided to the ability to work smarter, faster, and be more competitive. So I just want to give a big thank you to the SME group again, and to Patrick and Chris for joining me in this, and for everybody who joined. We really appreciate it, and we hope we see you on the next one.
Yes, thank you so very much to Aaron, Chris, and Patrick from CADDi for joining us today and sharing such an insightful presentation on this timely topic. So, and I also want to thank, our attendees for your participation and great questions. We hope you found the content valuable, and we'll hope to see you again soon. Until then, remember that SME and SME Media are here to help you stay up to date on all things manufacturing. You can find links to podcasts, webinars, publications, and news by visiting us at advancedmanufacturing.org. Thank you so much, everyone.